Hello, this is Professor Merrill Lichty. In this video, we're going to look at problems involving the binomial distribution. And here's a typical example. 15% of taxpayers cheat on their income taxes. Either they don't report all of their earned income or overstate charitable contributions and so forth. And we're going to randomly select 12 of these. And of the 12, we want to know, first, the probability that exactly 2 cheated on their taxes, that 2 or fewer cheated on their taxes, at least 4 cheated on their taxes, and the expected value and standard deviation of the number out of those 12 that cheated on their taxes. We're going to solve these probabilities in several different ways. First, we're going to do the old-fashioned way, just plug the numbers in to the formula, and then we're also going to look at Minitab and Excel to do it the easy way. Now, before we do any of this, we've stated that this is a binomial distribution problem, but maybe we should verify that by looking at the assumptions and the setup of the problem. So if we let x equal the number of taxpayers out of the 12 who cheated, is x really a binomial random variable? So for a binomial random variable, we have to have a fixed number of trials, and in this case, that would be observing whether a taxpayer cheated or not. And we have 12 of those, so that is fixed. Second, each of the trials results in one of two options, success or failure, and we have that here. Either they cheated or they didn't cheat. Next, the probability of success on any of these trials has to be the same, and what we mean by success in this case is finding somebody who cheated, and we're told that 15% of the taxpayers cheat, so that's going to be the same for each of the trials, so that's satisfied. And finally, we have to have that the trials are independent of each other, and that's something that's actually difficult to verify, and I'm not quite sure how to do that, but I think it's reasonable to assume that how one taxpayer behaves does not affect another taxpayer. So we're going to go ahead and use the binomial distribution for this problem. So let's look at the first problem. What's the probability exactly 2 cheated on their taxes? And we're going to do this the old-fashioned way. So here's the binomial formula. You can see this from either the textbook or the notes. And the parameters that we're going to use here are n is equal to 12, that's the number of trials, pi, that's the probability of success, in this case 0.15, and x is the number of successes that we're interested in this case 2. So we're going to apply this formula with n equals 12, pi equals 0.15, and x equals 2. And this is what it looks like when we plug all of those numbers in. So let's break this down a little bit so we can plug it into our calculator easily. 12 factorial is just 12 times 11 times 10 times 9 times 8 all the way down to 1. 2 factorial is 2 times 1, and 12 minus 2 is 10, so 10 factorial is 10 times 9 times 8 all the way down to 1. And then we have 10 factorial in the numerator and 10 factorial in the denominator. That actually makes it nice because those are going to cancel out and you don't have to push the buttons on your calculator as much. And so that leaves us with 12 times 11 divided by 2 times 1. And then we have the pi to raise to the second power and 1 minus pi to the 10th power. So that's 66 times 0.004430, or 29.24%. Which means that there's about a 29% chance that 2 out of 12 people cheated on their taxes. We're now going to skip to the final question because we're going to do this one without software as well. In this question, we're being asked what the mean and the standard deviation are for the number of people who cheated on their taxes out of 12. And so if you look in your notes or in the textbook, you'll find the formula for the mean is just n times pi, and I think that makes sense. If you have n trials and there's a probability of success pi, then you would expect n times pi of those to be successes. And the formula for the variance is very similar. It's n times pi times 1 minus pi, we actually want the standard deviation, which we will get by taking the square root of that. So we're simply going to fill in the blanks. N is 12, pi is 0.15, and so we see the mean of x is 1.8, and the variance is 1.53. To get the standard deviation, we simply take the square root of that. We get 1.237. So you might be looking at this and saying 1.8 cheaters per 12 taxpayers. That's never actually going to happen, is it? No, because you can't have 0.8 of a cheater. But what this means is if you were to repeatedly take samples of size 12, on average, you would have 1.8 cheaters. So you might have 0, 1, 2, 3, 4, 5, or whatever you get. And if you average all those numbers, then you get the mean value. So we've got some other problems to solve, but we're going to move on to using software instead of doing it by hand, and you'll see why we do that. The basic thing we need to do in Minitab is to use the calc function or menu and then go to probability distributions and then binomial. And when you do that, you'll see this window pop up. So we're going to look at the first problem again, the probability that exactly 2 cheated on their taxes. And let's go over to Minitab to actually do that. So here we have Minitab, and this is a calculation we're doing. So we're going to go up here to Calc, and then Probability Distributions and Binomial. So again, that's Calc, Probability Distributions, Binomial. And you see the same windows that we have. We want probability. This is going to be the probability that x is equal to some value. And number of trials, we have 12. What we're calling the probability of success, Minitab calls the event probability. That's going to be 0.15. And then for the x equals 2 part, Minitab calls that input constant. So we're going to say x equals 2, and then we say OK. And the result we get back is given here, binomial with n equals 12, p equals 0.15. So they're calling pi p, and x is 2, has a probability of 0.292358, which is consistent with what we got when we did it by hand. So this is nice because it's easy to catch mistakes here. This is telling you exactly what's going on. You have a binomial random variable, n is 12, p is 5, and x is 2. So you can look at this and say, oh, that is actually what I wanted. So back to Excel, we see that we get what we were looking for. So the next question says, what's the probability that 2 or fewer cheated on their taxes? And you can see here that we have the same window, input window, for the binomial distribution. The only thing that's different here is instead of using the probability, we're using a cumulative probability. So let's come back over here. Again, it's calc, probability distributions, binomial. Everything's already pre-populated, so I just need to change this to cumulative probability. And what this means is the probability of being less than or equal to the number that we're interested in, 2. So we get 0.735818. And here is that output. The final question asks the probability that at least 4 cheated on their taxes. That means 4 or more. And we just saw that Minitab thinks in terms of cumulative probabilities in much the same way as it does probabilities. So if we want to think about this, we can say that x is either going to be less than or equal to 3, or x is going to be greater than or equal to 4. And if we add up the probability of those two things, that's the entire probability of all possible outcomes, so that has to be equal to 1. And so if we want the probability that x is greater than or equal to 4, we can just solve for that and take 1 minus the probability that x is less than or equal to 3. Now the reason we do this is because this is very easy to plug into Minitab, as we just saw. All you have to do is change the value of x, and we see that the probability that x is less than or equal to 3 is 0.907794. So to get the probability that x is greater than or equal to 4, we just subtract that number from 1. So the solution we're looking for here is 0.092206. All of this is very cool, but there's even more we can do. And let's look at the probability distribution for all of the values of x. So we can do that in Minitab by making a column that is called x, and it has all the values that the random variable can take on. So 0, 1, 2, 3, 4, all the way up to 12. You can just type these things in, or you can figure out some way to make Minitab do that for you. And then we're going to come over here and say calc probability distributions binomial again, and we're going to change it back to probability because we want the probability associated with each of these values of x. And then we're going to change from input constant to input column. And when we do that, you'll see that this x column is now available. So select that, click OK, and you will get the probability distribution for all the values of x. So basically what's going on is Minitab goes and computes the probability that x is equal to all of these values and give those to you. So the one that we looked at before, probability that x is equal to 2, that's given right here, 0.2923. And the cumulative probability would be found by adding the 0.923, 0.3, and 0.14. And this is something that's very useful. And so now let's shift gears and look at Excel. If we want to use Microsoft Excel, find probabilities associated with the binomial random variable, we can do that using the function binom.dist. So if we wanted the probability that x is equal to 2, we would say equals binom.dist. The first input is x, so that's 2. The second is n, that's 12. The third is the probability of success, 0.15. And then the last one is an indicator function or variable that tells us whether we want a probability or a cumulative probability. So if you put 0 or false into that fourth argument, it's going to give you the probability. Alternatively, if you want a cumulative probability, so the probability x is less than or equal to 2, just change that from a 0 to a 1 or false to true, and that will give you the probability that you're interested in.